In tech support, we get the question all the time, where should we set our heat pump lockout temperature? Many companies have a rule of thumb as to where to set this lockout. The only real way to set it accurately is by plotting a balance point sheet for the equipment you are working with. The balance point of a heat pump is the outdoor temperature at which the heat pump can no longer meet the heating demand of the home and will need additional backup heat to maintain the temperature in the home. So this is a general heat pump balance point chart, and here we see a number of points that are plotted on this chart. Point A is the heating load at 99% of design temperature. Point B is the heat pump heating capacity at 17 degrees, which is derived from the AHRI directory. Point C is the heat pump heating capacity at 47 degrees, which is also derived from the directory. And where these two lines intersect is point D, which is our balance point temperature. So in this particular example, at 25 degrees, this heat pump would need backup heat to maintain the temperature in the structure. So as we stated, you would have to check with the AHRI directory or look at the product data for the heat pump that you're working with to get the capacity at 17 degrees and also at 47 degrees. And with these two numbers, you can plot your balance point on a balance point worksheet. Now, as we stated before, a lot of companies have a rule of thumb that they lock out the heat pump and go on auxiliary heat. And many companies lock out the heat pump at 30 or 35 degrees. Well, here's a balance point sheet that has been worked out for an inverter-driven heat pump with an outdoor EXV doing the metering. You'll notice that the balance point at minimum capacity is 15 degrees, and at maximum capacity, the line doesn't intersect the load line until well below -5 degrees. So if this company would lock out their heat pump at 35 degrees, they would miss out on operating the heat pump down to -5 degrees, which the heat pump has the capacity to maintain the temperature in the space by itself without any backup heat. And once again, by checking the AHRI directory or the product data for the particular heat pump you're working on, you can determine the 17 degree temperature and the 47 degree temperature and the capacity at which the heat pump will be operating to plot your balance point worksheet. So here we have a balance point sheet for a standard heat pump with a standard scroll, no inverter, with an outdoor piston metering, not the EXV, and we still get some outstanding performance. You'll notice that the one machine, the balance point is at 20 degrees, and then progressively goes down to 0 degrees, and some of them don't even meet the load line. So by setting the cutoff heat pump temperature above 30 degrees, once again you would miss out on the capacity that this heat pump has to run down to 0 degrees. Now here we have an example of a balance point worksheet for a 25-year-old heat pump with a scroll compressor and a piston outdoor metering device. So this is where some of the companies have gotten the idea of setting the outdoor heat pump cutoff point at 30 degrees or above. On this particular worksheet, we find that the balance point is actually at 30 degrees. But you can also note that some of the units go down to 0 degrees. So again, we make the statement that it is not possible to accurately set the heat pump cutoff temperature by rule of thumb, but a balance point sheet should be worked for the particular heat pump that you're working on to get it set and get the maximum capacity and efficiency out of the compressor. So as we have shown throughout this video, we need four numbers to plot a balance point chart. First, you need the heating load of the house at the outdoor 99% design temperature. Next, you need the heating capacity of the heat pump at 17 degrees, which is obtained from the AHRI directory. Then you will need the heating capacity of the heat pump at 47 degrees, also determined from the directory. And then lastly, you'll need the heating load of the house where it is 0 and normally estimated at 65 degrees.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.